Greetings and welcome. Mr. Waddy here. We've been doing solving systems of equations with three variables and three equations. Yep. And today we're going to look at some word problems, an example from the book, as well as a couple from the practice. So here we go. In order to do these word problems, I recommend starting by defining your variables, which are going to be the x, y, z in this case. So let's give this problem a read through and see if we can spot what those are. So an amphitheater charges $75 for each seat in section A, $55 for each in section B, $30 for each lawn seat. There are 3 times as many seats in B as A, and the revenue from selling all the seats is blank. How many seats are in each section of the amphitheater? And so one of the tricks for defining variables is that like 95% of the time is my estimate, the variables are going to be the question being asked. So the number of seats in each section. And so section A and B and lawn would be those. So X equals, and we've got to figure out, it's not just X equals section A. We've got to figure out, does X represent the area of section A? Does X represent the price per seat in section A? The number of section A tickets that are sold, right? So I've got to be specific. And since this is asking how many, not how much money or whatever, it's going to be a quantity that this variable is representing. So number of section A is what I've got. Yeah. Y will be the number of section B, and Z will equal the number of lawn seats. All right. And so now that I've got my variables, I've got to write my equations. And so, let's see. Oh dear, let's see. Normally I've written these in different colors, but I'm going to have 3 separate equations. So let's break this down one sentence or fact at a time. They charge $75 for each seat in A, $55 B, $30 for the lawn. And then they make a total of that much money. So if I combine these facts, I could have $75 times the number of section A seats sold, plus $55 for the number of section B seats sold, and $30 for the number of lawn seats sold. And so that's all going to give me total amounts of money. And if I add all of those together, I should get $870,000. And so there's one equation. Another fact they gave me is that there's a total of 23,000 seats. And so since all 3 sections combined are the only 3 sections, we could assume that they all add up. All of these quantities of seats would add up to 23,000. So I'm going to write X plus Y plus Z equals 23,000. All right, so there's another fact. And a third fact seems to be hiding in this sentence. There are 3 times as many seats in section B as section A. Let's see. I'm trying not to. So my triple underline fact. So 3 times as many seats in section B. Section B is represented by Y. And now it's easy to write this the wrong way. 3 times, I could see and understand the temptation to write 3Y equals X. But the number of seats in section B is 3 times the number in section A. And so, yeah, be careful with that. It's easy to write the 3 on the wrong side. And one way to think about it is which one of these values, Y or X, has got to be the larger one. Y was the larger one because it has 3 times as many seats, and therefore I would need to triple the number of x in order to get that to equal y. All right, and so always kind of run your logic back through in order to do that. And so now that I've gotten my variables and my equations, I'm going to solve. And looking at this, I might... This one's already solved for y in terms of x. I'm tempted to do substitution here, I think. And so I'm going to plug 3x in for this y and for this y. And so up top, I'll have 75x plus 55 times 3x plus 30z equals 870,000. And then I'd also have here x plus... all right, let me do that one first, and then I'll simplify it. Tell you what. And to save us a little bit of space and time, I'm going to just do the 55 multiplied by 3 and add that. So 55 times 3 is 165. Add that to 75, and I get 240x plus 30z equals 870,000. Now, the fact that all of these have an extra 0, you could just immediately divide both sides by 10 and try to get smaller numbers. That's not a bad idea, but you don't have to do that. Let's see. So now for this second equation. So let's see. X plus 3, or plus y, which is now going to be 3x, plus z equals 23,000. And so I plugged in 3x there in place of y, combine those like terms, and so I've got 4x plus z equals 23,000. And so I'm going to call this my equation D and this my equation E. If I was labeling, this one would have been my A, B, and C. All right, so a lot of the work is just kind of keeping track of these things. And so notice the fact that I substituted for y twice has eliminated the y in both of these equations, and now I have a system of 2 equations and 2 unknowns, something that I might remember how to do from the days of Algebra 1. And I can now solve this. I could try to figure out elimination method, but I think I'm just going to do substitution again. And I like this equation's z. So I'm going to subtract 4x from both sides, and I would get z equals, I'll explain why. I like this equation z because it has the positive 1 coefficient, that it's easily solvable. So let's see. And so if this is what z is equal to, I could plug that into the other equation's z. And so I'm writing equation D here with this substituted for it. And so 240x plus 30 times, instead of z, I'm going to write this, equals 870,000. And so I'm plugging in negative 4x plus 23 hundo. I made a mistake all the way back here. So 240x minus 120x. Now 30 times 23000 is plus 690000 equals 87 with 4 zeros. Okay. All right. Now I get the 120x. This is the challenge here, is a single mistake. Fortunately, we knew enough to look for it once we started getting some negatives. But I suppose I could still be wrong and have a positive answer, couldn't I? 18000. And now divide both sides by 120. And I'm getting x equals 1,500. All right, so what does that represent? The number of seats in Section A, assuming we did this correctly. And so now I can plug this in here, and I get z equals -4 times that, plus... oh, friendos. It's all right. It's all right. Let's see. Multiply that by -4. I get -6,000 plus 23,000. And so I'm going to get z equals 17,000. Now, I mean, I've already been talking about making mistakes. Yeah, I got that right. So that is the number of lawn seats, right? And I know that if I go back up here, that's what z represented. And so now the only thing I've got to figure out is what's the number of seats in section B? Bravo. And the easiest place to find the value of y is right here. I technically could use this equation and plug in my value of z and my value of x and solve for y, but this one looks even easier. So I'm going to do the y equals and plug this. Plug this in up here. And so I get y equals 3 times x, which was 1,500. And so I get y equals... All right, guys, I so don't trust myself now, but I believe that's 4,500. Yeah, that's the case. That's the case. And so now I get the value of y, the number of seats in section B. And so what's the question that was asked? How many seats are in each section? So I defined the variables, I wrote the equations, I solved the problem, right? And so now I can answer, and a word problem needs a word answer. There are 1,500 seats in section A. This is the hardest part for me as a math guy. Writing out all these sentences takes so long because I'm used to typing. We're going to say 4,500 in section B. And 17,000 lawn seats. Boom. All right, there we go. There we go. And we figured it out. And so even if, assuming you don't make numerical transcription errors like I did, even if you know how to solve systems of equations very well, the hard part for you might have been interpreting the word problem, right? And so defining your variables, writing those equations, that's a whole other story. And so let's see, depending on how long this video is going, we'll see how far we get. So here's some from the practice problems. I wanted to give you some additional examples that we could do together. And so I might not solve the whole problem, but I'll at least help you on the setup. We'll see what I got. And so 3 bouquets of flowers ordered at a florist, 3 roses, 2 carnations, and 1 tulip, blah, 6, blah, blah, blah. And then, okay, so they gave me different facts. So I'm going to start by defining my variables. And my variables, in this case, are defined in the question being asked. How many does each item cost? So that's not the cost of the bouquets, that's the cost per flower. And so x equals, tell you what, cost per rose. And it's not a bad idea to label units measured in dollars. Y is the cost per carnation. Dollars American. And the reason I'm choosing that is because that's the unit that I saw there. And Z is the cost per tulip. All right. And so let's write our equations now that I've defined my variables. So they had this one fact up here. And so let's write that out. So 3 roses times the price per rose right? 3 roses times X would give me the total amount that all the roses cost in that bouquet, plus 2 carnations times the price per carnation, and plus 1 tulip times the price per tulip, which we could just write as Z, is going to equal $14. All right, so there's my first fact. And then my second fact, 6 roses plus 2 carnations plus 6 tulips was equal to $38. And then the last fact was 1 rose, 12 carnations, and 1 tulip equals $18. And so now that I've got all of those defined, we can solve our system. And looking at this, let me go sky blue here. Good old sky blue. If I was solving by substitution, either of these would be an excellent choice to solve for because they had a leading coefficient that's 1. In this case, we happen to have our variables and equal signs and constants all lined up. Elimination wouldn't be a bad idea either. So between 3, 6, and 1, 6 is the least common multiple. 2, 2, and 12 is 12. 1, 6, and 1 is 6. And so you could have gone the elimination strategy as well. I think because this video is going long, I want to keep cruising. And so let's keep going because it's the setups that's going to throw you guys off. Okay, here's another problem. A triangle, and I guess it's not quite as wordy as a word problem is, but here it says a triangle has a perimeter of 90 centimeters. Write and use linear system to determine the lengths of the sides. And so those are my variables. Oh, they already defined those variables for us. Right, and so my variables are L length, M, I could call this base 1 or something like that. It looks like this is a right triangle. I can't assume that. No. All right, so yeah, I guess I just have to call it like side 1. And you didn't necessarily have to write this down because they kind of defined them for us. M and N, boom, sides 2 and 3. And do I know? Oh, these are in centimeters, so I'm assuming these are in centimeters as well. And now when I write the equations, well, let's see what I've got. I happen to know. Oh, then they ask if it's a right triangle. They're not slow to read the problem here. Write and use a system to determine the lengths of the sides. And so I've got. Okay, all right. Well, the perimeter is 90, and the perimeter would be all 3 sides added together. And so I'm going to say L plus M plus N equals 90 is one fact using the perimeter. Then I've got another fact. They happen to give me this fact here. They said the length is equal to 5/4 M minus N. And then they gave me another fact right there that M was equal to 5N minus 5. And so here's my 3 equations. I would probably go substitution based on what I have here. You could substitute this in for M here and in for M here. You could get rid of the fraction on this equation by multiplying both sides. Tell you what, we'll do a little bit of work on this. I'm going to plug it in for this one first. L equals 5/4 M minus N. And I get 5N minus 5. And so I'm going to simplify this. 5/4 times that is 25/4 N minus 25/4 minus N. Oh dear. It's pretty gnarly there. And I want to combine these like terms, but I'd end up needing... Yeah, I'm going to multiply both sides by 4 here. It won't be as substitutable, but it'll get rid of the fractions for a minute. 25/4 multiplied by 4. Guys, I found my mistake. When I multiplied this side by 4, I did this part right, but this should have been a 4. No, guys. And so then this would have been 21. Oh, my friendos. And then that would have affected all the way down here to here. And then I would have subtracted 21n from both sides. Let's see if this helps. So 24 and 21, it would have been 45. Is 405 divisible by 45? It is. It is. Oh, boy. Well, there you go. This has been a lesson in how a single mistake feeds through an entire problem. All right. L should have equaled to 41. M should have equaled to 40. And N should have equaled to 9. And then those, if plugged in here, would have equaled one another and would have been a right triangle. Well, anyways, thanks for watching, internet friends. We did at least do the setup correctly every time. I just couldn't get the calculations to be error-free. Well, thanks for watching. Have a great day.